Nice to meet you. I'm Khadir Choktai and you're watching my YouTube channel. I'm going to explain how to solve chemistry paper Cambridge IGCSE Paper 2 multiple choice question extended Feb March 2020 2 variant. Let's get started. Question number 1. The formula of methane and formula of ethane. Formula of methane is CH4 and the formula of ethane is C2H6. Which row describes diffusion and relative rate of diffusion of methane and ethane? The first column is showing description of diffusion and the second column is showing the rate of diffusion. You know what is the diffusion? The diffusion is movement of particle from the region of high concentration to the region of low concentration. So from high concentration to low concentration, yes, it is correct. Come towards the B, that is having the same one option in first column, high concentration movement to the low concentration region. And the next one is, it's having particles move from low to high. No, it's wrong. And again, it is also low to high. Again, it's wrong. So either A or B could be the correct option. Now come toward the second column. In this case, you can see that which one is having the higher rate of diffusion. First of all, let me check their masses. CH4 is equal to 16 gram per mole mass and C2H6 is having 12 into 2 plus 6, 30 grams per mole. So methane is having lower mass, lower MR as compared to the ethane. So its rate of diffusion will be quicker. It will diffuse faster. So let's see over here. Methane diffuses more quickly than ethane. Yes, it is true. It's true. So overall, B is the correct option. B is the correct option. Question number 2. Which test is used to show the sample of water is pure? The test for the purity is basically melting point, boiling point. Evaporate the water to see, option A. Evaporate the water to see if any solid remains. Answer is no. Heat the water to check its boiling point. Yes. So basically boiling point and melting point are the basic tools, accurate tools to check the purity of the sample. So B is the correct option. You can say B is the correct option. Then second option, the next option C, test with anhydrous cobalt chloride that is used to check the presence of water, not to check the purity of water. And once again, D, universal indicator, again it is used to check the presence of water, not the purity of the water. Question number 3, chromatography is used to separate and identify the component in both colored and colorless mixtures. For colorless mixtures, chromatogram has to be treated with another chemical. What is the name of this type of chemical? So for colorless compounds, we need locating agent, and here it is. We need locating agent, and D is the correct option. D is the correct option. Question number 4. Lithium react with fluorine to form compound lithium fluoride. Lithium fluoride. Which statement about this reaction is correct? A. Each fluorine atom gains 1 electron. Let's see over here. In this compound, as you know, it's an ionic compound. F negative ion is over here and lithium positive ion is over here. Then each fluorine atom has gained 1 electron. Yes, it is true. Yes, it is true because it's showing 1 negative charge. So this one option is the correct option. However, let me check the other options as well. Each fluorine atom gains 2 electrons or more electrons. No. Each fluorine atom loses, not at all. Each fluorine atom loses, again, no. So A is the correct option. Question number 5, isotope of the carbon. There are the two isotopes, carbon 14 and carbon 12 are the isotope of the carbon. Which statement about these isotope is correct? A option, carbon 612, carbon 12 is more reactive than carbon 14. No, because reactivity does not depend upon the change in the mass or the mass only. It depends upon the number of electrons present in the valence shell. B, again, it's more reactive and have the different number of neutrons. No. The reaction of carbon 12 are similar to the carbon 14 because they are having the same outer shell electron. Yes, it is true. As they are having same number of electrons, six electrons are there in both cases, so they are having the same chemical reaction, same chemical reactivity because of the outer shell electrons. Question number 6, the molecular formula of the hydrazine is shown. Which description of the bonding in hydrazine is not correct? Let me mark, first of all, let me mark the lone pairs on the nitrogen atom. These are called non-bonding electron as well. And these dashed line are called bonding electron. These are bonding electrons. But this lone pair is said to be, this is said to be lone pair. Or non-bonding electron. While these are said to be bonding electron. Bonding electrons. So, which description of the bonding in hydrazine is not correct? Each nitrogen atom has a non-bonding pair of electron. Yes, it is having. So first of all, let me check the correct one. It's the correct statement. Each nitrogen atom has 4 bonding pair of electrons. You can check it, 1, 2, and 3. 4 bond, no, it's having 3. Each nitrogen atom is having 1, 2, and 3. 3 bonding pair of electrons surrounding it. So it's not correct. Each nitrogen atom shares one of its electron with the nitrogen atom. Yes, each nitrogen atom is sharing one electron mutually with the other nitrogen atom. Yes, it is correct. Each nitrogen atom shares 2 of its electron with the hydrogen atom. Yes, each nitrogen atom is going to share its 2 electron with the hydrogen atom. Yes, it is correct. Yes, it is correct. So he is asking not correct, and the not correct is the B option. So B is the required option, is the correct answer. Question number 7, solid X has high boiling point. Its structure has positive ion surrounded by the sea of electron, means he is talking about the metal. Which other properties does solid X have? Number 1, are option A, brittle and electrical conductivity. No, metals are never brittle. Pure metals are not brittle. They are not brittle, and they are not insulator as well. C, malleable and electrical conductor. Yes, they are malleable and they are electrical conductor, good electrical conductor as well. So C is the correct option. Question number 8. The formula of the some ions are shown. In first column there are positive ions. In second column there are negative ions. In which row is formula not correct? Let me check one by one. Aluminium and oxide, I mean aluminium oxide, aluminium positive ion and O2 negative ion. Aluminium is having 3 positive charge, O2 minus, minus positive will cancel out, 2 over here and 3 over here. So Al2O3 is the correct one and its name is aluminium compound, aluminium oxide. Yes, its compound's name is aluminium oxide. Yes, it is true. Come towards the B option. It's iron 2 nitride. So its oxidation state must be 2. I mean iron 2. What is the formula of iron 2 nitride? With nitride. Fe 2 positive and 3 negative. Negative and positive will be cancelled out. 3 over here, 2 over here, and the formula will be Fe3 and 2. And here it is wrong. So this is not correct. This formula is not correct. Sodium sulfate, Na2SO4. Here is a sodium. Here is sulfate. Sodium 1 positive and SO4 2 negative. 2 negative and positive will be cancelled out. 2 over here, 1 over here, and formula will be Na2SO4. Yes, it is correct. Name is also correct. Zinc nitrate. Zinc is having 2 positive charge and nitrate ion is NO3, 1 negative. Negative and positive will be cancelled out. 1 over here, 2 over here, and it will be equal to zinc nitrate twice. ZnNO3 twice. So it's also correct. 1 is incorrect and he was asking about not correct. I mean B is the correct option. B is the correct option. Question number 9. The equation for the decomposition of magnesium nitrate is shown. Which volume of the gas is produced when 0.1 mole of magnesium nitrate is decomposed completely? Let's see over here, when 2 mole of magnesium nitrate is going to decompose, how much different gases, 2 type of gases are going to be formed, and what are their total moles? 4 plus 1, 5 moles of the gases are formed. So 2 mole of the magnesium nitrate is going to make 5 mole of the gases. 2 mole of magnesium nitrate is going to make 5 moles of gases. And here we are going to decompose 0.1 mole. So 5 by 2 into 0.1. This will be the mole of the gases. Mole of gases that will be born. And to change mole into dm cube, we will have to multiply with 24. So the answer of mole will be multiplied with 24. 5 by 2 into 0.1 into 24. 2 12s are 24, you can say. And 12 into 0.1 into 5, the answer is 6. So 6 dm cube will be the total volume of the gases at room temperature. At room temperature. Let's see over here. C is the correct option. C is the correct option. Question number 10. Which statement about electrolysis of the molten lead to bromide are correct? Lead to bromide. I mean, this mixture is having Pb 2 positive ion liquids and Br 1 negative ion, or 2 mole of Br 1 negative ion liquids. Lead ions move towards anode and are oxidized. No, it is having positive charge. It will not move towards anode. Lead ions move towards cathode. Yes, it's correct. And What will happen then? It will gain electron and it will change itself into lead solid, and they are reduced. Yes, its number is going to be reduced from +2 to 0. So yes, it will be reduced. So 2 is the correct option. Bromide ions move towards anode. Yes, they may be because they are having negative charge and they will lose 2 electron. I mean 2Br, negative ion will lose 2 electron to make Br2, gas or liquid. And what is happening in this case? -1 is changing into 0. In this case, number is going to increase, so it's oxidation. So it's oxidation. Yes, 3 is also correct. Bromide ion move towards cathode. No, they cannot move towards cathode because they are already having negative charge. So 2 and 3, C is the correct option. Question number 11. Aqueous copper sulfate is electrolyzed using carbon electrodes. Which statement is correct? Bubble of the hydrogen are formed at anode. Hydrogen, in this copper sulfate solution, let me write first. Cu2 positive ion aqueous will be there. SO4 2 negative ion aqueous will be there. From water, H positive ion aqueous and OH negative ion aqueous will also be there. So which one ions, I mean negative ion, from the negative ion, which one ion is the winner ion? That is OH negative ion. And which one positive ion will be the winner at cathode? That is the copper one. So bubble of the hydrogen are formed at anode. No, at anode OH negative ion will be there and it will make oxygen gas. 4 OH negative ion goes to 2H2O, 2 mole of H2O, and 4 mole of electrons and 1 mole of oxygen, and it's a balance equation. So the first one is the wrong one. Bubble of the oxygen gas are formed at cathode. No, cathode is going to welcome this copper 2 positive ion. Copper is deposited at anode. No. The blue color of the solution will fade, yes, because copper 2 positive ion is going to deplete with the passage of time as it is moving towards the cathode, and there will be the deficiency of copper 2 positive ion in the mixture, so color will be fade away. So D is the correct option. Question number 12. Nitrogen trifluoride is used in manufacture of certain type of solar panels. The equation for the formation of nitrogen trifluoride is shown. N2 plus 3F2 goes to 2NF3. Type of bonds, and the second column is showing bond energy. Using the table of the bond energies, what is the energy change of this reaction? I mean, he is asking to find the answer of delta H of this reaction. The formula is delta H is equal to bond energy of the reactant minus bond energy of the product. So what is the bond energy of the reactant? There are two reactants. One is N2 nitrogen and N triple bond. So N2, that is having 950 kilojoule, plus you can say 3F2, I mean 3 multiplied by FF bond energy, that is plus 150, and bracket close minus. Now it's turn to put the answer of the values of the product. 2 into NF3. I'm going to write the structure of NF3 first. This is the approximate structure, normal, that is not up to the scale, you can say, or not according to the Vesper theory. It's normal structure. So 3 NF bonds are over here into 3, then NF bond. So overall 950 plus 450, you can say, and minus 2 3 are 6. 6 into its bond energy is 280. NF bond energy is 280. The overall answer will be equal to, I'm going to add first of all the amount of the reactants, 950 plus 450, that is 1400, minus 1680. So the answer is basically 280, and that's minus 280. So B is the correct option, the correct answer. Now come to our question number 13. Which statement about the hydrogen fuels are correct? Number 1, reaction between hydrogen and oxygen is endothermic. No, it's wrong. The reaction between hydrogen and oxygen is exothermic. It's always exothermic. It's always exothermic. So this is incorrect. The waste product in the hydrogen fuel cell is water. Yes, it is correct. A chemical reaction in the cell produces hydrogen, which is used as a fuel. No, it's not going to produce hydrogen. It consumes hydrogen. A hydrogen fuel cell is used to generate electricity. Yes, direct current is generated by the fuel cell. So 2 and 4, C is the correct option. Question number 14. Which change is physical? Number 1, which change is physical change? Which one is not going to go through the, you can say, a chemical process where there is no chemical process happening? Number 1, copper carbonate changes color from green to black when it is heated and stay black when it cools. If it stays black when it is cool, then simply it means it's going to be changed chemically. And the reaction is basically this one, CuCO3. When copper carbonate is heated strongly, it makes CuO, that's a black solid, and it will make CO2 gas. This is the black solid, and that is irreversible reaction. So this is the chemical change, it's not a physical change. First A is incorrect option. Ethanol react with oxygen to form carbon dioxide and water. Ethanol react with oxygen to form carbon dioxide and water. Ethanol is going to change itself into CO2, carbon dioxide, and water. So you can see that the formula is going to change. Ethanol is going to change itself into new chemical species. One is CO2, other one is water. Again, it's a chemical change, it's not a physical change. Hydrogen peroxide decomposes into water, and oxygen decomposes, it's a chemical change. The last one, the one and only, D is the correct option. Ice forms liquid water when it is heated. Yes, it's a physical change. So D is the correct option. Question number 15. A student add excess magnesium ribbon to 10 centimeter cube of 0.5 mole per dm cube sulfuric acid. Hydrogen gas is collected and its volume measured every 10 seconds. The experiment is repeated using the same mass of the magnesium ribbon with 5 centimeter cube of 0.5 mole per dm cube of sulfuric acid. But this time there is addition of 5 centimeter cube of the water as well. In this experiment, he or she is doing dilution. He is going to dilute the solution of sulfuric acid. Same magnesium ribbon is going to be used, and this time less volume of acid, sulfuric acid, is being used. And now the 5 centimeter cube additional volume of the water is going to be added in this experiment. So let's see over here. Basically, this magnesium ribbon is in excess. You can see that it's in excess. So it's not going to change the yield of a chemical reaction. Which one is the limiting reactant? This one, sulfuric acid, is the limiting reactant. How many moles are there? Let me calculate it over here. 10 multiplied by 0.5 divided by 1000. That is equal to the mole of sulfuric acid used in this experiment. Mole of sulfuric acid used in this experiment. Let me calculate first. 10 multiplied by 0.5 and 5 divided by 1000 is equal to 0.005. So 0.005 mole of sulfuric acid was used in this original experiment, that is shown by the dotted line. In this experiment, the concentration of sulfuric acid is equal to 0.005 mole. Keep in mind, it is behaving as a limiting reactant. And this sulfuric acid, H2SO4 is behaving as a limiting reactant. Number two, it's also in form of solution. That is an aqueous solution. So this sulfuric acid is going to control two things. Number one, it is going to control yield. Number two, it is also, controlling the speed of reaction. So both factors will be changed by the sulfuric acid. What are the new number of moles of the sulfuric acid? In this case, you can see it over here. 5 multiplied by 0.5 over 1000. And mole is equal to 0.0025 moles. So half mole, initially there were 0.005 moles. In second experiment, in repeated experiment, moles are 0.0025 moles. So now we are using half moles of sulfuric acid. So the vertical line will be lower down, it will be at half. For example, you can see it over here. Whenever you are using 0.005 mole of sulfuric acid, the yield that is equal to this one. Let me try it again. So this is the original yield, the yield of the first original experiment. That is equal to, you can say, 120 volume of the hydrogen is being formed. As you are using the half mole of sulfuric acid in this case, then the new yield will be equal to this one, that is 60. So half yield will be there, and so on. So D is the correct option. The second one, as you are going to add some water molecules, some sample of the water into that sample, you are going to dilute the sulfuric acid. Because of dilution, the speed will be the lower down, and it will be away from the y-axis as compared to the original experiment. The repeated experiment will be away from the y-axis as compared to this dotted line experiment. So once again, D is the correct option. Now come towards the next one, question number 16. An equilibrium reaction is shown. N2O4 goes to double arrow, a reversible arrow goes to 2 mole of NO2. The forward reaction is endothermic. This is the forward reaction, and this is the reverse reaction, or backward reaction, you can say. This is the forward reaction is endothermic. We can also write it over here. Heat plus N2O4 goes to 2 mole of NO2. What is the effect of changing temperature and pressure? Changing temperature, that is increasing temperature, right? Increasing temperature favors the endothermic side. So the forward reaction is endothermic. So reaction will move forward. Forward mean this is the right hand side of the equation and this is the left hand side of the equation. So because of increase in temperature, equilibrium will be shifted towards right hand side. Will towards right. Now come towards the effect of pressure. By increasing the pressure once again, increasing the pressure, equilibrium will be shifted towards that side where there are less number of moles. You can see that in this case 2 mole are on the right hand side, 1 mole is present on the left hand side. So equilibrium will be shifted where there are less number of moles on increasing pressure, so it will be moved towards left hand side. So overall you can say by combining the two column, C is the correct option. Question number 17. In which reaction is the underlying compound acting as reducing agent? Which one is a reducing agent? First of all, which one is a reducing agent? That oxidizes itself and reduces other. So it oxidizes itself and reduces other. Number one, you can say in this case, CO2 is going to lose oxygen, so it is going to reduce itself. No, it's wrong. In second case, underlying element is carbon and it is changing into CO2. I mean, it's gaining oxygen, it's oxidizing itself. Yes, I mean, it's correct. In this case, carbon is acting as a reducing agent. So B option is the correct option. You know, carbon and carbon monoxide and potassium iodide are the famous reducing agent as far as the level of IGCSE syllabus is concerned. Question number 18. X, Y, and Z are oxides of element in the same row of the periodic table. Some information about each oxide is shown. Now let's see over here. This number one column is showing the solubility in water. It's soluble, insoluble, slightly soluble. Ability to neutralize the acid, no. Ability to neutralize the alkali, yes. So the X1 is water soluble and it is going to react with alkali. So it is a non-metallic oxide. It's a non-metallic oxide, as it's acidic in nature and it's neutralizing the alkali. Come towards Y, it is insoluble. It is acting with acid, yes. It is acting also with the alkali, yes. So, I mean, it's an amphoteric. It's an amphoteric oxide. It can neutralize the both species acid as well as base. Slightly soluble, the Z1 is slightly soluble and it's acting with an acid, reacting with an acid, and it's not acting with an alkali. I mean, it may be the metallic oxide. And the second one is a basic oxide. It's basic oxide. The first one is an acidic oxide. Second one is an amphoteric oxide. This one may be Al2O3, I think, the most probably you can say, and so on. So let me check the options now. X is acidic, there's one and only. And Y is amphoteric, yes, amphoteric. And Z is basic, yes. I mean, the first row, A is the correct option. Question number 19. 4 different acids are dissolved in water. Which beaker contains most concentrated strong acid solution? 2 things are over here. Those should be considered very much efficiently. Number 1, concentrated. Number 2, strong. I mean, concentrated acid mean having high reservoir of H positive ion, and high quantity of molecules. I mean, the second thing is strong, that is going to be show that there is the more, again, the loss of H positive ion into the aqueous medium. So these both factors are going to show the more quantity, more the majority of the H positive ion into that solution. Let's see over here. A, it could be A, yes, H positive ions are there and negative ions are also there. Come towards B. B, in this case, HY. I mean, this HY is unbroken molecule of the acid. So it cannot be a strong acid. It is not a strong acid because some molecule are still present. Those are in undissociated form. Come towards C. Again, they are having some molecule of the acids. Those are yet not broken, not dissociated. Again, it's wrong. Then come towards D. Yes, it could be. Now let me compare, and we are having the only two options, A or D. Which one is having more number of H positive ion? 1, 2, 3, 4 H positive ion are appeared. Apparently, this D is having, A is having 1, 2, 3, 4, 5, 6. So A is more concentrated and it is strong acid as well. So A is the correct option. A is the correct option. The following substances can be reacted together to prepare salts: copper 2 oxide and excess hydrochloric acid. Number 2, hydrochloric acid and excess sodium hydroxide, hydrochloric acid and excess sodium carbonate. In which reaction can the excess reactant be separated by the solution by filtration? By filtration. So let's see over here. Number 1, in this excess component is an aqueous solution. It cannot be separated by filtration. Filtration is used to separate the solid component from a solution. Number 2, hydrochloric acid with excess of sodium hydroxide. Again, this sodium hydroxide is an aqueous solution basically, and its separation doesn't need filtration. The last one, excess zinc carbonate. In this case, zinc carbonate is in excess. Yes, it can be separated because it's insoluble in water. It is not in form of aqueous, it is in form of solid basically. Yes, it will be separated by filtration. So finally, D3 only is the correct option. That's all for today. Thank you very much. Have a nice day.